Hello, here's a tutorial on activity 3.2.1, trends in temperature. We are going to start with what I consider the third section of this project, data cleansing using Python. So we're starting at about step 32. Feel free to follow along, conduct some of this work while you're watching, maybe pause here and there, try things out and move on. So I hope this is helpful. This part of the project is all about cleansing bad data from a data set. Sometimes when data is collected, there may be an inconsistent means of collection. There may be some values that were not put in correctly. There can be all sorts of things that lead to bad data or invalid data in a data set. And that just kind of confuses things here and there when you're trying to analyze the data or visualize the data. So what we are going to do is remove the data that's not valid or accurate so that we can have a more accurate representation of the data. So in order to do that, we're going to use the Python library pandas, which stands for panel dataset. So we're going to use the functions in the pandas library to cleanse the data from our Python dataset. We are going to first think about our dataset itself, which is all about carbon dioxide levels or concentrations in the air over time. So our background information is that carbon dioxide in the air can increase due to human activities such as deforestation, burning fossil fuels, respiration, volcanic eruptions, which are natural processes, those latter two. We're going to use Python to clean and analyze carbon dioxide data collected over the last several decades. So let's take a look at our data sets. I'm looking at CodeHS here. Here is the CO2 data.csv file, and it has some comments to introduce us to it. The average carbon dioxide is expressed as parts per million, or ppm, which is the number of molecules of carbon dioxide in every 1 million molecules of dried air. That means water vapor has been removed. Missing months are denoted by negative 99.99. So again, if we see a negative 99.99, that means that month was missing. Negative 1 means no data on the number of days. We have a lot of negative ones. So now if we look through the data set here, we see we have some categories. Year is the first value. Month is always going to be the second. Decimal year, which is right here. And then average, that's the average carbon dioxide concentration in parts per million. So we know that it's easy to understand the year. The month is, of course, where the month falls during the year, right? Number 3 would be March, number 4 would be April. This is something a little bit new, the decimal year. So this is the year, and then how far you are into the year out of 1,000. So we're getting the third month of the year, we're getting something around 0.2. Because there are 12 months in the year. So we don't quite come out in tenths. We're going to come out in something a little bit less round. So the 4th month in the year is a little bit greater. 5th month in the year, 6th month in the year is about half. That's about what we would expect, right? So you can see that the number gets quite high as we get to the 12th month of the year. And then now we get into 1959, and the first month of the year is a lower decimal value, right? We have 1959.042. whereas December 1958 was 1958.958. So this is kind of a good way of having a unique value that shows us exactly what year and month we are in, all in one value, rather than trying to decipher that in a way that is kind of repetitive, right? There are multiple records here that are 1958. There are going to be multiple records that have a 3 because March occurs once every year. So I already see 3 of them right here. So if we wanted to have a unique value for time, we would go with the decimal year, which I think is actually going to be quite useful to us. So Project Lead the Way has some questions about the data set. What is the unit measure for the carbon dioxide average and what does it stand for? We saw it was ppm, parts per million. What do you think the column decimal year stands for? We talked about that. What do the negative 99.99 and negative 1 values mean? Well, we already read negative 99.99 means that the data was missing, right? That was a missing month, and negative 1 means there was no data on the number of days. Great. Next, we are going to clean the data file by removing all the informational lines or comments, so you end up with only a header row and data rows. So that means we want to remove these comments because honestly, if our pandas data reader is going to read in this data, this is just confusing. It won't know what to do with all of the comments. So we're going to remove them for now. Next, 33 is done. Good job. Note this is a large file because it includes data per month, not just per year. Good point. Next, we're going to create a new Python program. I already created that for you in CodeHS. You can skip 34. 35, reuse the code from the temperature analysis program to create a program that reads and plots the carbon dioxide data. So first, we kind of already have some of that. Project Lead the Way gave you some starter code for the temperature data. Notice, by the way, that I'm using the carbon dioxide CO2 analysis activity in CodeHS. So this file looks a lot like the temperature analysis file, but it's different. It's actually the same starter code, but we're going to do this in a different project. So we are going to take we can kind of use this as a template. So we were working with temperature data. Let's make this CO2 underscore data. And we're going to use this pandas module to read the CSV file. And what's our CSV file called? CO2 underscore data.csv. So that will be CO2 underscore data.csv. Great. Okay. And then we want to actually make that graph. I think Project Lead the Way is going to give us some guidance. Plot the CO2 averages as a line graph. Which column should we use for the x-axis? Well, we can kind of see it down here if we look ahead, right? We're looking at the years, and the suggestion is we actually want to use the decimal year because it's a unique value. Like we said before, the year values repeat about 12 times. The month values repeat because that month occurs every year. So if we use the decimal year, we're definitely going to get something unique. So let's make this is the part where we were using matplotlib to make the line graph. So anywhere where it says temp data, I'm going to make it CO2 data. We're going to use this plot function to create the line graph. We have our CO2 data. The x-axis is not going to be year, it is going to be decimal year, correct? I'm literally going to copy and paste so that I don't have any differences in the spelling, the capitalization, the underscore versus a dash. You know, you really want to be very consistent so that you don't have a bug. So we're going to change where it was year to be decimal year. And then this value for the y-axis is not going to be anomaly. You can probably guess we're going to be graphing what is the average carbon dioxide level for that month. So here we go. We're going to get that into main.py right about here. So PLT refers to the nickname we created for matplotlib, the mathematical plotting library. We're going to use the plot function and refer it to the decimal year on the x-axis and the average carbon dioxide levels on the y-axis. And here we had been using the gray color in our last project. I'm going to just you know, to play with this and make sure we are all exploring matplotlib a little bit. I'm going to try a new color and see how it comes out. The Y label we said is average carbon dioxide levels, and that's in parts per million. And the X label, I think we'll say years. Is that what they did over here? Let's check. Yep, years. Great. And we see the CO2 levels. Okay. Is there anything else we need to do before we, change in carbon dioxide levels. And of course, if we were going to test making our graph, we need plt.show. Let's see how it works. Oh, look at that. I see something orange. I think the orange worked. So we have a graph that shows us carbon dioxide levels over time. The average carbon dioxide levels look like they're ranging from -100 to about 400. That seems like a big range. And we're running this from, I think we said the first record was 1958, so this looks about right before 1960. And it's going until about 2020. So about 60 years. And if you look, there's definitely a trend happening here, although we have these dips sometimes. So one question you might ask yourself is, why do we see these dips? And that's exactly what Project Lead the Way is asking us. Notice the value of the dips, right? They're just about at -100. What else was at about -100? You may be thinking of that -99.99 value that represents a record where some data was missing. So that is this is what we're talking about when we're talking about bad data. These are kind of isolated errors, or not even an error, just something was not available that prevented us from having accurate data, and instead we have this placeholder, and it's not going to help us if we want to take a really close look at the valid data. So how can we go about removing these records? Well, depending on how many there are, you could go manual, right, and just go through and look for that -99.99 and delete it by hand. That's a possibility. But the nice thing is that Python can help us do it in a more automated way. We're going to do, for we're going to use the math module in order to do this. So we've got to find our import statements and import math. So you see there are some imports up here. That's where we're importing the matplot library. I can just say import math, no abbreviation. Great. Step 39, insert the following code segment right after you load the data into the data frame object. So this, luckily, Project Lead the Way is providing us with some code to clean our data set by removing those records with a negative 99.99. And it is suggested that we start doing that as soon as we import the data. Okay, so CO2 data dot drop NA subset average in place equals true. So this is one way that we are removing records, right? If you look carefully, this is where we read in our data from the CSV file here. Here, if we look at our data and the average column, we're replacing any negative 99 values with this object from the math library, NaN. That stands for not a number. So it's some kind of symbol that is not a number. Then we're using this pandas function, drop NA, drop not a number, I think. And we're going to use that to remove any data that has the NA value in the average column. So if you try that, then you should be able to remove the data that's not valid. So in order to check if this is working, if we were able to successfully remove the data, well, one thing we could do is just see how our line comes out, right? This time we shouldn't see those dips that we saw before. And we don't, right? We really just see a more consistent trend. And the nice thing is, because we're not trying to cram values ranging from 400 to negative 100, we can kind of zoom in. Things are only running from 400 to about 300, so about 20% of the range we had before. And that gives us access to a little bit more of the variety you see as the months go on. And the nice thing about this data is it's really easy to see a trend. And you can start thinking about what is happening and why. Another thing that we can do to check whether or not this cleaning effort was successful is we could print our data set. So that's one suggestion. Project Lead the Way gives us a suggestion of using print, simply that data set. And we can put that in after each of these changes that we made to the data set. And before we made changes, we're going to see that result too. So we're still getting our graph up here. And one thing that's different is down here we are seeing some data. So we see we have several columns. We have, and do we see any values with the negative 99? We do, right here. So this was a case where the measurement was missing. That month there, perhaps it wasn't taken, perhaps the record got lost, but we had an instance where we have this negative 99.99 as a placeholder, just to convey that we tried to gather data, but there was none. So then this function, this line of code here, is the one where we replace any negative 99.99 values with the not a number. So let's look for record 3 right here. And we do see the average has been replaced with not a number in record 3. And then finally here, we are doing a drop. We're dropping not a numbers, or drop NA, from the average column. So you'll see that in this case, that whole line of code, line 3, is going to disappear. It's going to be dropped. And you're going to be left with a data set that goes 0, 1, 2, 4. So the fourth record happened to be one that needed to be removed. And it has in fact been removed. So we already tested our plot. We've taken a nice look at our data. You can kind of scroll through and see how that worked, the project lead the way perspective when you have a chance. Congratulations, your data analysis is complete. You did it. So take a few minutes to look at these conclusion questions. This climate site is where the temperature data and the carbon dioxide data came from. And there are other data sources that you can access here. It's really, really interesting. And there are other visualizations of data that you might find interesting as well. So good luck with the project. Please do let me know if you have any questions in class, and take care.